open up. You OPN, hit you on BBM. We should be closer than friends.
Hi, my name is Alina Jacob, and today we're going to learn how to derive the quadratic formula. Let's get started.
So, in order to derive the quadratic formula, we're going to need the quadratic equation. The quadratic equation must be in its general or standard form. The standard form for a quadratic equation is ax squared plus bx plus c equals 0. When we're given this equation, we're normally asked to solve for x, or find all the values that make the equation equal 0. You can do this in numerous ways. You could graph it, factor it, complete the square, or use the quadratic formula. When we're using the quadratic formula, we're actually taking a formula that was derived from the equation itself. So let's find the quadratic formula. To derive a quadratic formula from this quadratic equation, we need to first complete the square of this equation. So we need to subtract c from both sides of the equal sign. So minus c, and you will get ax squared plus bx equals negative c. Now we have moved the c from the left side of the equation to the right side. We now need to look at the x squared's coefficient, which is a. The reason we are looking at a is because in order to continue completing the square, a needs to become a 1. So in our next step, we need to divide the equation by a in order to get the 1. So divide by a. A divided by a is 1, so we can write it as x squared plus b over a x equals negative c over a. So now we have 1 as the coefficient of x squared. So now we're going to focus on the left side of this equation in order to turn it into a perfect square trinomial and continue the completing the square process. The reason we're turning this into a perfect square trinomial is so later we can factor it out. But we need a middle term for our perfect square trinomial. In order to get the middle term, or the value we're adding to the left side of the equation, we're going to focus on b over a, which is the coefficient of x. In order to get our middle term, we're going to divide 2 with b over a and then square it. So we're going to take b over a, and dividing by 2 is the same as multiplying by 1/2 because we're taking half of b over a. So multiply by 1/2 equals b over 2a. And then we're going to square it. This equals b squared over 4a squared. Look, we now have the value of b squared over 4a squared. We have found our middle term to put into the left side of this equation in order to make it a perfect square trinomial. So our next step, we're going to add this term to both sides of the equation, keeping the equality on both sides. So we're going to do x squared plus b over a x plus our term b squared over 4a squared equals negative ca, and remember we're adding it to both sides of the equation, plus b squared over 4a squared. So now we have a perfect square trinomial on the left side of the equation. So in our next step, we're going to factor this out. So I just rewrote our equation we just found with our perfect square trinomial, so we have room for the next step, which is to factor. We're going to factor out our perfect square trinomial. So when we factor it out, we get x plus b over a, then squared, equals negative c over a plus b squared over 4a squared. Nothing happened on the right side, but when we look at the left side, we factored out our perfect square trinomial, which thus we completed the square from our original standard form of ax squared plus bx plus c equals 0, which is what we originally started with. So in our next step, we're going to simplify. So in order to simplify, we're going to focus on the right side of this equation, since we have two fractions that we can't add because they don't have the same denominator. So in order to add them, we need to find the least common denominator between the two. This fraction right here has the least common denominator of 4, so we just need to focus on negative c over a. So we can write this as negative c over a, let me just rewrite that, equals negative c over a times 4a over 4a. Again, we are doing this in order to change the denominator so we can add it to b squared over 4a. And speaking of b squared over 4a squared, we just add it over here. B squared over 4a squared. So we can multiply this out and we get negative 4ac over 4a squared. Then don't forget to add b squared over 4a squared. Perfect. Now we can write out the whole equation once more. So we get x plus b over a squared equals b squared minus 4ac over 4a squared. So now we have x plus b over a squared equals b squared minus 4ac over 4a squared. But we're trying to solve for x. X is located in the binomial that's being squared. So in order to solve for x, we need to take the square root. So let's rewrite this. So we're taking the square root of x plus b over a squared equals b squared minus 4ac over 4a squared. So we square root this, and we end up getting x plus b over a equals plus or minus the square root of b squared minus 4ac over 4a squared. So now you see, even though it's a little slanted, that I wrote plus or minus the square root of b squared minus 4ac over 4a squared. The reason I put this plus or minus is so when we're square rooting, we don't know if the value is negative or positive. So this establishes the uncertainty. So now we have this equation, and we notice that we can simplify even more on the right side. So we can write x plus b over a equals plus or minus the square root of b squared minus 4ac over 2a. The reason we write 2a is when we square 2a, we get 4a squared. So the next step is to subtract, because look, x is almost by itself. So in order to make x by itself, we need to subtract. So we subtract b over a, and we get x equals plus or minus the square root of b squared minus 4ac over 2a minus b over 2a. So now our last step is to just simplify. So our final, which is the quadratic formula, we are able to get x equals negative b plus or minus the square root of b squared minus 4ac all over 2a.